Welcome to online class of Malabar Engineering College. Okay, today we're gonna take on a subject machine design 2, which comes under S6 automobile. Okay, the topic we're gonna discuss here is about the piston. Okay, we know in an automobile engine the important component is an engine, and the moving component in an engine is the piston. That's the main moving component which is situated inside the cylinder. Okay, here we can see a sample picture of a piston. A piston consists of like a piston pin, 3 compression rings, 1 oil ring. Like this is for compression. These 3 rings are meant for compression purpose, and this one is an oil ring, and the oil ring is placed for removing the oil, because the cylinder comes here and the movement occurs and there should be no friction between the piston and the cylinder walls. So the oil is provided between the gap, and this oil is supplied using an oil ring. So it's provided over here. Okay, now let's discuss a problem on the base of a piston. Okay. Following are the given data for the piston of 4-stroke diesel engine. The engine we are supplementing here is a 4-stroke diesel engine. The cylinder bore is around 250 mm. The cylinder bore, that's the cylinder around shape bore of the piston is like around 250 mm. The material of the piston ring is grey cast iron. The piston ring is made of grey cast iron. Allowable tensile strength, like the maximum tensile strength that is permissible inside a piston is about 100 Newton by mm square, and the allowable radial pressure on the cylinder wall, like the cylinder walls, the maximum pressure that can be applied is 0.03 megapascal. Thickness of the piston head is 42 mm. The thickness of the piston head, the topmost part of the piston is the piston head, and that's around 42 mm. Okay, number of piston rings. That's here we see the number of piston rings is like 4 piston rings are supplied, 3 compression rings, 1, 2, 3, and 1 oil ring. And total altogether there will be like 4 rings around it. Okay, now first step, let's write the given data. First we have the diameter bore, cylinder bore diameter D is equal to 250 mm, and the allowable tensile strength is like 100 Newton per mm square, and we have the allowable radial cylinder pressure wall, like the pressure is 0.03 megapascal. We convert this pressure to Newton per mm square. The same value 0.03 Newton per mm square it comes. Then thickness, like the thickness of the piston head TH is equal to 42 mm, and the number of piston ring Z is equal to 4. And these are all the given data. Now first we need to calculate the radial width of the piston ring, like the radial width of the piston ring. First step is like the radial width of the piston ring, H is equal to D into root of 3 PW by sigma T, which is given in the data book. And we substitute in the value 250, D we have 250, and we have 3, and PW, the value of PW here 0.03 Newton per mm square, and divided by sigma T tensile strength, like we have 100 Newton per mm square, and substituting these values we get the radial width of the piston ring as 7.5 mm. And next, after the second, we need to calculate the axial thickness of the piston ring, like the axial thickness of the piston ring, and for that the data book equation gives like H minimum is equal to D by 10 into Z, and D is the diameter, and that's 250. Like cylinder bore is the cylinder diameter itself, like cylinder bore we have 250, and divided by 10 into Z. Z is the number of piston rings inside it, that is 4. By substituting that we get the value 6.25 mm. So we know how to calculate the radial width of the piston ring and the axial thickness of the piston ring. And this is a simple problem. By this I conclude my today's class. Thank you.